So, Common Core, what have we been doing? The entire Common Core has been about triangles. So it is G for geometry. CO10. It's been the same one most of this unit because what we've been doing is proving theorems about triangles. Alright? Okay, example 1 needs names. So I'm going to highlight something. It's circled, but I'm going to highlight the whole thing about side names and angle names. Alright? So for side names, we've got things like isosceles, scalene, and equilateral, right? Those are our side names, okay? So let's take a look at it. First of all, triangle WXZ, okay? WXZ, okay? So if these two are angles are equal, these two sides are equal, this side's got to also be equal, right? So we're not going to call it equal angular, we're going to, by sides, we're going to call it equilateral, okay? All three sides equal, WXZ, so how about equal lateral? Okay. All three sides are equal, it's an equilateral, okay? WXY, WXY. Well, let's see. Seems to me as if all three sides are different lengths, so that's got to be scalene. Right? All three sides are different lengths. It's called a scalene triangle. The last one, XZY, XZY. I see this little dash here and this little dash. When those two are equal, makes it an isosceles. Even though I didn't draw it very well because that doesn't look the same, but remember, I drew this. I'm a bad artist, but if that dash is there and that dash there, then these two have to be equal. Even if they don't look like it, because I'm a lousy artist, it's isosceles, okay? Always remember that. Don't just look at a figure and assume that it's drawn correctly. Never do that, okay? I'm not an artist. Okay, thumbs up. Okay, now, by angles. Well, if you're going to label something by angles, you could have an acute triangle. You could have an obtuse triangle. We can have a right triangle, right? Those are by other names. We can have an equal angular, okay? Those are all the ones by angle. So WXC, WXC. So there's two names, and we're going to use both. We're going to call it an acute equal angular, okay? All three angles are equal, makes it equal angular. All three angles are less than 90, so it's 60, 60, 60. So it's an acute equal angular, okay? WXY, WXY. Well, there's a little right angle bar here, isn't there? So this triangle's got to be a right triangle. Because of the little box, WXY, I've got my little angle, my little right angle there, so it's got to be a right angle, okay? XZY, XZY, well, we're talking about this triangle that's orange, and that angle's certainly bigger than 90. In fact, I know that angle's 120. Has to be 120 because I know that one's 60. So this one's an obtuse triangle. Thumbs up. So you name it by sides with sides are going to be the scalene, isosceles, equilateral, those sides. By angles, we're going to have acute, right, obtuse, and you can even have an acute equal angular, okay? Good. Let's move on. Okay, now the next one. So we don't know any coordinates, but we got to figure out what these other things are. So first of all, this point right here, right smack dab where they cross at the origin, that's easy. What's the coordinate of that one?
0, 0.
Yeah, everybody agree? That's got to be 0, 0. Okay, that's got to be 0, 0. I agree. Now let's figure out this one. So if I go back A to here, right? That's distance of A. And then I'm going to go a little bit more with a B, right? Then all the way out is going to be negative A, and then the distance of B, this one's just going to be a negative A, the negative A minus B. I should have made this bigger. and then the corresponding, oh, I did that wrong. I did. X value, negative A, and my, no, I did it right, negative B, but something's wrong here because I call that a C. It'd be really a negative C, wouldn't it? It'd really be a C, a negative C. There we go. Back A, back some more B gives you A and B, and then down C. Okay? That was a little trickier, isn't it? So if I go back A, and then I have to add on a little bit of B to it, it'd be the negative A minus B, and then I have to go down C. Okay? That was a little harder to see. Alright, the dreaded proof. The dreaded proof. Well, okay, when I do a proof, I do a couple of things. First of all, I read keywords. I do really three things. Before I even start, I look for keywords. Okay? I look at the picture and look for things in the picture, and then I try to figure out what in the heck am I trying to prove, right? Doesn't that make sense? So let's go through this. So keywords, all right, first of all, perpendicular. Okay, perpendicular to me means probably 90 degrees, so I'm going to mark my figure perpendicular. So AC is perpendicular to BX, on my little box, okay? I'm going to mark it so I can see it. It helps me because I can't remember things that well. Maybe it's because I'm old, I don't know. Anyway, if I mark it, I can see it, right? Midpoint, okay, if it's a midpoint keyword, it's got to be the middle, which of course it means it's going to cut something in half, right? Midpoint cuts something in half, and if it's in half, I get two equal pieces. So let's see, X is the midpoint of AC, so most likely I'm going to say that this side is equal to this side, right? Somewhere in there. And then if I need to say probably the two triangles are congruent, I probably need to come up with a third thing. So along the way, I'm going to say this angle, these two sides, and probably this BX equal to itself. Those would be my three things. I made my plan. You guys with my plan? So here's my plan. I've got perpendicular, so I'm going to think, okay, I want to make that angle equal to that angle, right? Midpoint, so I want to be able to say that side's equal to that side. And then I'm probably going to use reflexive to say that side's equal to that side. Then I'm probably going to have a side angle side. Once I get the triangles congruent, I can say, well, CPCTC, corresponding parts congruent, triangles congruent. And then I think I'm going to be on my way. So let's begin. Step one. Given. Don't miss step one, please. Given. Even if you absolutely say, Mr. Davies, I cannot do proofs, at least get the given right, okay? Now, let's see. We're going to say that angle AXB and BXC are right angles. Okay, so let's put that in there. Why are they right angles? Well, what does it say up here? If they're perpendicular, right? So if things are perpendicular, that makes right angles. So we want to say something about the perpendicular. Even if you put the word perpendicular in here, I'm going to be happy, okay? Definition of perpendicular lines, how's that sound? How about definition perpendicular lines? Because we know that two lines are perpendicular if they cross at right angles, right? Okay, right angle theorem. What do I know about right angle theorem? Well, aren't all right angles equal, right? So let's say that. Let's say that these two angles are equal. So I'm going to say, how about angle AXB is congruent to angle CXB. You can't say angle X is equal to angle X. I'll say it again. You can't say angle X is equal to angle X, because which angle X are you talking about, right? You have to be more specific, okay? Unless they're completely isolated like A and C. All right, step 4. X is the midpoint of AC. Yeah, I think I saw that right up there. You guys agree? Given. Thanks, Katie. Well, now, if I'm going to say midpoint, I probably should use that information. So, if it is the midpoint, then I go straight to AX is congruent to XC. Well, I just said it was midpoint, so what do you think I would put here? Definition midpoint, right? If I say it's midpoint, then I say they're equal, it's got to be by something about midpoint. But Katie's right, it is definition of a midpoint. Okay, so I've got two things. I've got a side to a side, I've got an angle equal to an angle, and I need a third thing, and then this reflexive pops up. Well, they both share XB, don't they? XB is a side for this triangle, XB is a side for this triangle, so let's just say that BX is congruent to, actually it's also BX because they correspond. Sometimes we turn it around. If you don't worry about it. Reflexive, so now let me mark that. So now this side is equal to this. So all of a sudden I say two triangles are congruent. Triangle ABX is congruent to CBX. You cannot say two triangles are congruent unless you use one of these, right? When you say two triangles are congruent, it has to be one of these. Well, it's pretty obvious which one it is. Which one is it? Yeah, side, angle, side. I got a side to a side, an angle to an angle, and a side to a side. By side, angle, side, or SAS. There you go. SAS. Sounds like Anna, huh? Okay, now all of a sudden we want AB to be congruent to BC. AB congruent to BC. What do you think? So aren't corresponding parts of congruent triangles congruent? Aren't corresponding parts of congruent triangles congruent, right? Corresponding parts of congruent triangles congruent. We did it. How you like that? Okay, thumbs up. You're starting to get proofs, aren't you? No? Yeah?
Yes.
Yes. Kurt's got them, I know that. Okay, turn it. Hey, this looks familiar, doesn't it?
No.
This looks familiar. I think we just did a problem like this, right? Okay, so graph A, B, C, D, where A is -3, -1, A, 0, 3, 1, 2, 3. Please graph carefully. The only time I see kids really mess up on this is when they graph the points in the wrong place. Don't do that, okay? 5, 3, 1, 2, 3, 4, 5, 1, 2, 3, and 2, -1. Okay. All right. Draw my figure in. Let's put my figure in there. Looks like a parallelogram, doesn't it? I might be off. Am I off by one? Oh, see what happens? Didn't I just tell you that? And look what I did. Man. Good thing I just mentioned it. See what happens when you graph them wrong? I did not do that on purpose. It does mess you up if you graph the points wrong, doesn't it? So here we go. A is -3, -1, so A is there. I looked at it and thought, that doesn't look right. Here we go. Now that looks better. Now it looks like a parallelogram, doesn't it? Looks like a parallelogram to me. All right, find the slopes. AB and CD. Ready? 1, 2, 3, 4. 1, 2, 3. So I'm going to go a 3 squared plus a 4 squared equals a C squared, right? Okay, let me go ahead and highlight my little triangle in here. So I'm just using this little right triangle right in here. You guys see it? There's my little right triangle. So Pythagoras theorem, A squared. So I got a 9.
That's on the length thing. Or wait, slope.
Oh my goodness gracious. I got distracted. The phone, I'm just wondering who wants me. Anyway, let's go back to the slopes. Up 1, 2, 3. Up 1, 2, 3, 4 over 1, 2, 3. So the slope is 4 over 3. Thanks, Claire. Up 1, 2, 3, 4. 1, 2, 3. Up 4 over 3. Okay? Got it. What's the slope of AD? What's the slope of AD? No, 0. It's up 0 over 1. Up 0 over 1. Up 0. It's up 0 over 1, but that's just 0, right? Up 0 over 1. Up 0 over 1, which is just 0, right? Okay. Now, if opposite sides are parallel, then it's probably going to be a parallelogram, okay? Now, let's do the lengths, okay? Thanks, Claire. I got a little ahead of myself, didn't I? Okay, let's make our little triangle. A squared plus B squared equals C squared, right? Made my little right triangle. 1, 2, 3, 4. 1, 2, 3. So 3 squared. That's a lousy looking 3. 3 squared plus 4 squared equals C squared, right? 9 plus 16 equals C squared. 25 equals C squared. Hey, what do you know? Same number again. Why do I keep choosing this one? Because it works out nicely, right, Jaden? I keep using this 3, 4, 5 triangle over and over again because it makes nice numbers. 5, okay? So I know that the length of AB is 5. Okay, let me write that in. That's the length of 5. And I know that I've got the exact same triangle over here. Okay, I got the exact same triangle there. Oh, thanks, Katie. Got the exact same triangle here. 1, 2, 3, 1, 2, 3, 4. So I already know that the length of CD has got to be 5 also, right? It has to be because it's the exact same triangle. Now what about the length of AD? Well, the cool thing about AD is you can just count it straight across, right? I mean, these are true squares, right? 1, 2, 3, 4, 5. Okay, it's also 5. Okay? 1, 2, 3, 4, 5. It's also 5. Oh my goodness, it's more than a parallelogram. It's something even more significant. Anybody know what it is? It starts with an R.
Rhombus.
It is a rhombus. A rhombus is a quadrilateral with 4 equal sides. It's a rhombus. And a rhombus is a parallelogram. Hey, like that. Can you do this tomorrow? Yes? No? Yeah? Okay, well, all right. We'll see. Okay, it's a lot of homework, but the reason we have a lot of homework is because we have a test tomorrow, okay? Now, real quick, Megan brought in her scale drawing. I want to show the scale drawing to you. Let me go ahead and kill the recording.